So in this video, I'll be talking about amplitude and period for the assignment given in class. Amplitude, if we take a look at this, this general sketch of a sine curve, then I've got marked here that our amplitude is the distance from what we would call the line of equilibrium, where it's neither increasing nor decreasing, to the max point. Technically, we could say the distance from here to here, since the distance from your line of equilibrium to your max or your line of equilibrium to your min would be the same in this case, since it's at y equals 0. So what we need to understand is that amplitude in our sine or cosine function is always going to be the number in front of sine or cosine. So this will be the factor that either vertically stretches or vertically compresses our function. Think about it like if we were listening to sound waves, if we were able to visually see the sound waves, an increase in amplitude we can equate to turning up the volume. If we turn up the volume, the waves are going to be higher. Okay? If we cut down the volume, the waves are going to be lower, and therefore the amplitude would be decreased. If you think about amps put in a car to increase or maximize the push of sound out of your speakers, then by putting in an amp, it helps the car to be able to, or the speakers rather, to play higher volumes. The other factor we're going to be talking about is the period. The period is the horizontal length of one complete cycle of the graph. We've already learned that for sine of x and cosine of x, the period is 2 pi, meaning we should be able to start and finish the graph of sine and cosine in a length of 2 pi on our graph. The amplitude for both of these functions would be an understood 1 here in front of both sine and cosine. So just in general, for sine x and cosine x, the amplitude is 1, while the period is 1. And that should make sense. If this was our sine curve and my max was here at 1, and my min here at -1, my amplitude would be 1. So it's actually always half the distance of your max and mins, kind of the average. Find your average of your max and mins. That'll give you your line of equilibrium. And look at the distance from your line of equilibrium to the max point. And recognize that it's always the a value of your function. Period has a formula, and that formula is that b is equal to 2 pi, period is equal to 2 pi divided by the b value of your function. So if you look at the sine function here and here, it's the value that's going to be in front of the x. So just remember that formula. It's very important. Your period is 2 pi for the sine and cosine function. If I change up my sound waves and actually create a different pitch, it actually changes those sound waves. So what I want to do next is just make sure you have a good understanding of what happens. If we just take a general sine function, and I'll do that for each of these, and we'll talk about the 4 different possibilities. So let's think of this as just a regular sine function with our max at 1 and our min at -1 and our period at 2 pi. That's a little hard to see. 1, -1, and 2 pi. So if I want to think of think about when a bird is say it's tweeting outside, and it's not very loud, it's pretty quiet. So since it's quiet, we could think of it as the waves would not be as high, but they have a very high pitch. If you think about a bird tweeting, it's a high-pitched noise. So when the pitch changes, the waves get closer together if it's a higher pitch. So this would be representative of like a bird chirping. If we have a bird chirping, then we're going to have a higher frequency, which changes the period. So for those of you that are musically inclined, this should also help to make sense. So think about a high-pitched noise. If you were to look at the waves would be closer together. So think about that. The period is normally 2 pi. So what that does is it, in fact, compresses it vertically and compresses it horizontally. The waves get closer together. So that changes your period. So a bird chirping, that's high frequency. This would be an example of high frequency but low volume. So frequency, remember, affects the period, and that volume, that's representative of your amplitude, right? So your high frequency affects the period. It would actually decrease the period, but a low volume would decrease your amplitude. So another scenario we might consider is, what if you heard a lion roar? If you heard a lion roar, those are males, and usually males have deeper voices, so those roars are going to be really loud, but the pitch is going to be really low. Think about a male's voice versus a female's voice. A female's voice is higher pitched, meaning the waves are closer together, while a male's voice is lower and it stretches out the frequency. So if a lion roared, we could think of this as it would be really loud, and the waves would be more spread out because it's a lower frequency. So this would be an example of low frequency. So low frequency means a higher period, or a higher number for your period, and high volume. So that's going to result in a higher amplitude. Okay? Larger period, probably larger would be better than higher, but it's going to be stretched out. So recognize that as a horizontal stretch and a vertical stretch as well. Another example, if we were, let's see, to beat on like a small drum. Drums usually have a lower tone, and of course your volume depends on how hard you hit it, but they're usually drums you think of as loud. So think of a drum, or maybe not a small drum, but a larger drum. For a large drum, it would create a lower frequency. Well, that would be like the lion roar. Let's do small drum, I'm sorry. So if it's a smaller drum, the frequency is going to be higher. It's going to have a higher pitch, but it would be really loud. So think about drums as loud, but the smaller the drum, the higher the pitch. So larger waves, but a higher pitch means our frequency is going to change there, right? Or the waves would be closer together. The other and last example here, let's see, there were 4 of them. We need to do, what are we missing here? We've got high frequency, low frequency. That's high frequency, so we need a low frequency and low amplitude. So a low frequency and a low amplitude, just think of a male singing quietly. Oops, sorry. If you think of a male singing quietly, it's going to have a larger wave, but if they're quiet, then the waves are not going to be as high. It's going to decrease amplitude. So that would be the 4th condition, all right? So that's kind of, in general, what happens to our waves based on the frequency or the pitch and how that has an effect on the period. And then, of course, amplitude referring, you think of it like the volume, like of a sound wave. The larger the sound, the higher the amplitude, and vice versa. The lower the sound, the lower the amplitude. So things you need to remember. You need to remember that period is 2 pi over b. And, of course, you need to remember that amplitude is the vertical stretch factor, vertical compression factor. And this b value is what we're going to use in here for our period. And just like we talked about before, if it happens to the x, then that's a horizontal stretch or compression. That should remind you of the change in frequency. All right, so in terms of homework, what you're going to have to do is to first identify the amplitude and period of every function. So I'm going to want you to do amplitude for each one and period for each one for every single problem. Amplitude equals, period equals, and I'll just do a couple of them with you. Remember, your amplitude is your A value. It's the letter in front. If it helps you, at the top of the page here, write y equals A sine B times the quantity x minus C plus D. And one thing I like to do to help students remember is that A comes before F in the alphabet, just like A comes before B. So A is your amplitude, and the next letter is it helps you with your frequency. There's actually a formula for frequency, but think about that as affecting your period, and that B value is what you plug in for period. So, of course, remember that period is 2 pi divided by B. All right, so amplitude for number 1 would be your A value in front, so that's 1. Your period is 2 pi over B, so if you think, okay, well, I need to know my period, and that's 2 pi over my B. Oops. I wrote that wrong. 2 pi over B, which would be 2 pi over 4, then your period, if you reduce 2 over 4, is going to give you a half. So your period would be pi over 2. And if you think about it, that makes sense because that should be a horizontal compression by a factor of 1/4. So 1/4 the normal period of sine, which is 2 pi, 1/4 of that is going to be pi over 2. For number 4, your amplitude would be 4. Your period, if you don't see a number, it's understood to be 1. So 2 pi over 1 is just 2 pi. And then I'll do one with the negative value. So the reason why, I'll do number 6. So the reason why number 6 has parentheses here is because without the parentheses it would look like minus 4x. So your amplitude is going to be 2 here, while your period will be 2 pi over negative 4. Or we should say the absolute value of that. So don't even worry about the negative. That just causes a reflection, and that'll be pi over 2. We'll talk about those reflections tomorrow too. So pi over 2 for that period. And for right here, remember absolute value of A is your amplitude. So even though your A value is negative 4, the negative just means it's going to be vertically reflected, but your amplitude is 4. All right, so let's talk about number 10 next. It says give the amplitude and period of each function graphed. Your amplitude is going to be the distance from the equilibrium line to here, so that's a distance of 3. Your period is the length that it takes to complete one cycle. If we consider the origin here, all the way to here. This, by the way, recognize that this here is 2 pi, so this is pi. So it finishes a cycle in pi. So now it says write an equation for each graph. So that means we've got to think, well, what would my equation be? Well, if it starts here at the origin, remember that's the sine function. So far we know that this is 3 for our amplitude times the sine. But what we need is our b value. Well, we kind of have to work backward here. If 2 pi over b is our period, and we know that our period is pi, we can solve this algebraically or think, what does b have to equal in order for the 2 to cancel out and get pi? So hopefully you recognize that as 2, but I'll just show you. So 2 pi over 1, we can make it look like a proportion and cross multiply. But then if 2 pi equals b pi, then b equals 2. So that's what we put there. 3 sine 2x. Okay? I'll do a cosine one next. So if we take a look at number 11, we know to use cosine if it starts here, the max is on this vertical axis. So that would be one cycle, and you can see it's one cycle fits into a period of 2 pi. So our amplitude is 4, and our period is 2 pi. So if our period is 2 pi, then hopefully you understand that if 2 pi over b equals 2 pi, then b must be equal to 1. So therefore, we should have y equals cosine, oops, sorry, I forgot my amplitude. 4 times the cosine, that's b equals understood 1, so I just need 4 times cosine x. If b was another number, I would just put it in front of x. All right, so let's skip down here and talk about how we graph these. It says for 14 through 19, it says give the amplitude and period, then graph the function over the interval from negative 2 pi to 2 pi. Well, if you look down here on your graph, what you see is degrees. So please go ahead and mark that this is negative 360. And if it tells us to graph it from negative 2 pi to 2 pi, then we should correlate that negative 360 is negative 2 pi, and that positive 360 is 2 pi. So we should graph from negative 2 pi to 2 pi. So for number 14, and these graphs correlate, if you look to the right here, it says 14, you're supposed to graph y equals 3 sine x. So if we want to graph the sine function, we should know we start at the origin here and end here at 2 pi. Unless there's a number that changes the frequency or the period, then it's a period of 2 pi. Remember that for the sine function, your max and min are, you got to look at your amplitude. So what this shows us is that here, instead of starting at having your max be at 1, it's going to be at 3. So we just need to make sure that we mark 3 and negative 3 on our vertical axis. So remember, the sine function has zeros at the beginning, end, and halfway in between. Halfway in between there, it's up. Halfway in between there, it's down, your min. And this should be similar, same thing. Zeros at negative 360 or negative 2 pi, negative pi, and 0 pi, with a max here and a min here. And it should definitely appear symmetric about this origin, meaning we should be able to flip it down and then over. All right, so that would be from negative 2 pi to 2 pi, just by recognizing the amplitude is 3, and because b is 1, our period is still 2 pi. So let's do one that has, let's do 18. So if we go over here to 18, that's 3 sine x. That one's off. This is actually, they've got, I've got the functions typed in here backward. So for 18, if you look at 18 on the other sheet, it's really 3 cosine 1/2 x. And then on 19, it just needs to be switched. Y equals negative cosine of negative 3x. So remember, for all of these, by the way, you can go ahead and just type it in your calculator and check it out and see which ones make sense. Or just look at your calculator to see what the graph should look like. But let's go ahead and start with 18. So we want to start with our cosine function here at our max, but our max is going to be at 3 because our amplitude is 3. So again, we need 3 and negative 3. And if you think about what I apologize, if you think about what we talked about in terms of the b value being 1/2, that should be a horizontal, if you think about it, a horizontal stretch by a factor of 2. So that means instead of completing one full cycle in 2 pi, it's actually going to go all the way out to 4 pi. So at 360, we have 2 pi. Let's go ahead and mark negative 360 here, which would be negative 2 pi. And 720 is 360 times 2, so that's 4 pi. So if we're going to do one complete cycle, we need to go ahead and put 4 pi there. Although it says to graph from negative 2 pi to 2 pi, but I'm going to ask you to do the full cycle over here. So remember, for the cosine function, it kind of looks like a V, so it's a max. And then let's go ahead and, if we think about that period is 2 pi over 1/2. 2 divided by 0.5 is actually 4, so 4 pi. So that means you would start here and end at 4 pi 3. Halfway between the beginning and end is at 2 pi, and we go down to our min. Halfway here, from the beginning to 2 pi, is our x-intercept, and halfway between the half and the end mark right here is also an x-intercept. So this would be one period of 3 cosine 1/2 x. So the only thing, what we're doing here, if we're just going to negative 2 pi, it should be a reflection here. So if this is 2 pi, then this would be negative 2 pi. Halfway between here should be a 0. So from negative 2 pi to 2 pi is still here. But that way we can see both the left side and a full period on the right. of the vertical axis. I hope that helps. Just please go ahead and recognize that your amplitude will be your max or your min. Will help you find your max and min. And the b value, plug it into 2 pi over b to help you find the period. And that should give you your beginning and your end point. Okay? Text me if y'all have any questions while working on the assignment.